Data dependencies. Data dependencies are a set of ordering relationships between computations. A parallel execution of a serial program must respect data dependencies in order to maintain the original code semantic. Otherwise, the code is not computing the same thing. As long as you respect the data dependencies, a parallel execution produces exactly the same result as a serial execution. Static data dependencies are typically computed by compilers, and they are a superset of the actual data dependencies at runtime. It's an approximation, but that approximation captures all data dependencies that happens at execution time. Here is an example where we have been able in previous courses to parallelize this example, because here I am writing an array. The array I'm reading is different, and between the iterations, each iteration is using a different element of the array. So I have no constraints order on this computation. So I can execute this iteration in any order. It will produce exactly the same result. The background for the data dependencies representation are the Bernstein's conditions. Let's assume you have for a statement S, a set of variables register memory location used by the statement, that's called in, and assume you have the out set, which is what is modified by S. Then I can say that I can have the equivalence between the serial execution, S1 followed by S2, in a parallel execution, S1 in parallel to S2. Okay, that can mean S1 is executed at the same time at S2, or S2 is executed before S1 if I have this condition. So they don't share the same modified variable. If some variable is modified by one statement, it is not used by the other one, and vice versa. The only thing that is okay is to have in of S1 inter in of S2 different from empty, so they can read the same variable. So we have three kinds of dependencies. The first one is a flow dependency or true dependencies, and this is denoted S1 delta S2. And in that case, a data is transmitted from a statement to another one, and that's interesting to program computation. So here is an example. I have X that is produced by S1 and that is read by S2. Just to convince ourselves that you can't run them in parallel, I cannot do S2 followed by S1, because in that case, imagine X as V1 in here. This is producing value. S2 would be computing its values using the old value of X, which is V1. Another kind of dependencies are anti-dependencies. In that case, it's denoted delta minus 1. And these one are not due to the computation, but due to the fact that you are reusing memory location. So again, if I switch S1 with S2 in the execution order, I won't compute the same thing. In that case, let's assume this is producing V1. S1 here would be computing with X equal V1, which would not be producing the same state. One way to remove these dependencies is to rename this X, for instance, with X prime here, and in the remainder of the code, and the dependencies, in that case, will be gone. I can have the execution in any order, S1 or S2. Output dependencies, in this case, this is noted delta OS2. This is due to writing to the same memory location, and again this can be solved with variable renaming or removing the useless computation. In some cases you cannot remove the computation. So in here, let's assume this is V1, V2. If I switch S2 with S1 in the execution order, X will end up being V1. I have two ways to fix that data dependencies. In some cases I can remove that statement because it is useless. It's not always the case. Or because somebody else might be using X somewhere. Or I can rename X prime and in the remainder of the code. In that case, because this is dependencies just due to reusing the data, due to reusing variable, it disappears if I rename this variable. Here are a set of questions on data dependencies. What kind of data dependencies can be removed, cannot be removed? What are the data dependencies in the code on next slides? Here is this one. Remove as many data dependencies as possible in the code on this slide. Here I want you to remove the data dependencies by renaming the variables. What is a drawback of variable renaming? When is a static data dependencies computation correct? So what are the properties that static, that is at compile time, computing the data dependencies correct? And what do you call a code with no entry and output dependencies? So the examples of code and some references. That's the original paper from Bernstein. And see you in class.